All right, Algebra 1A students, welcome to part 2 of lesson 1-3. Today we're going to look at classifying and ordering numbers, okay? Starting with classifying numbers. We have a lot of different ways that we can classify numbers. One of them, which is very, very common, especially in this class, are what we call rational numbers, okay? And rational numbers are any number that can be written as a fraction. Okay, any number that can be written as a fraction. A lot of times we do see them as a fraction, so something like 1/2 or 3/4 or anything like that would be rational numbers. But it could also be a decimal as long as that decimal stops or starts repeating the same number over and over and over again. Okay. So mostly we're going to be looking at fractions here in this classification, but just know that it could also be a decimal that ends something, say, like 5.2, right? Because we know that we could write 5.2 as a fraction, 5 2/10, right? 2/10, 2/10. So rational numbers are any number that can be written as a fraction. And then within the rational numbers, we have three more specific kinds of numbers, but the key with these next three is none of them are allowed to be decimals. Okay, so within the rational numbers we have three sets of numbers, none of which are allowed to be decimals, none of which are allowed to have decimals. Okay, the most broad is called integers. Okay, integers is any number without decimals. So it could be a negative number, -1, -2, -3, -4, -5, -6, -112, or it could be 0, or it could be any positive number, 1, 2, 3, 4, 783. Any of those would be called integers as long as there are no decimals, okay? Now, a little bit more specific, we have the set of whole numbers, okay? The set of whole numbers, which is basically like the integers, but not allowed to be negative, okay? So we start at 0, and we go up 1, 2, 3, 4, 5, 6, 7, and forever up. Okay, whole numbers 0 and up. Okay, and then the last one is natural numbers, and those are the ones that we count things with in real life, like on our fingers. Okay, 1, 2, 3, 4. So any positive number that starts with 1, just the numbers we count with, the numbers we learned a long time ago when we first started counting. 1, 2, 3, 4, 5, 6, and so on all the way up. Okay. So these three sets of numbers are within rational numbers because we know that we could actually write any of these numbers as fractions, right? If I want to take any integer, for example, down here, and I want to write it as a fraction, all I have to do is put it over 1. Now it's a fraction. So yes, this most certainly is a rational number. This is a rational number. This is a rational number because I can put them all over 1 and make them into fractions. Okay? So these three are very specific types of rational numbers from above. Okay, so rational numbers are fractions, and then within those we have all these ones without decimals that we could write as fractions if we put them over 1. Okay, so let's do a little practice classifying a few numbers, and I want you to try to put these three numbers into one of those groups that we just wrote down up above. Okay, so your options are rational numbers, if that's as specific as you can get, integers, whole numbers, or natural numbers. Okay, so look at your four options and try to decide which one each of these falls into. All right, so pause the video, take a look here at these three numbers, and then come on back after you've classified them, and I'll show you what we should have. Okay, number 1, because it's a negative, that falls into integers. Okay, it is negative, but it does not have any decimals. So that one is a member of the integers. So we could just say integer. Okay. Now, number 2, 7 is a positive number like the ones we could count on our fingers. So that is a natural number. Okay, that is a natural number in number 2. And then number 3 looks like a fraction. It is a fraction. 7/3, 7/3 is a fraction. It definitely would be a decimal. if we tried to divide it out. So that is called a rational number. Okay, that one's a rational number because it's a fraction. So integer because that one's negative. Natural number because this is one we could count on our fingers. And then rational number because this is a fraction that we can't reduce at all. Can't be reduced, right? Okay, so now that we understand a little bit of classification, there's one other thing that I'm going to ask you to do in your practice problem sets tomorrow. And that is to order some different types of numbers from small to big. Okay? Now, in our last video, we looked at square roots, right? We looked at taking square roots of numbers, which we're going to have to do when we compare numbers as well. Okay, so some of our numbers are going to be square root numbers, which we'll have to practice on our calculator. Okay, so on your calculator, hopefully you remember where that button is, second x squared, or just find your square root button. Ask me if you don't know where it is, because we're going to need to use that to classify these numbers, okay? Now, the easiest way to classify, not classify, but to order these numbers from small to big is going to be to write them as decimals. Okay, so we're going to write everything as decimals if we can, right? So, for example, here they're asking us to compare the square root of 17 and 4 1/3. Okay? Now the square root of 17 is something we could estimate on our calculator. We could punch that in our calculator and it comes out right here. 4.12310, and then it keeps going forever. Okay, but it's 4.123 basically. And then 4 1/3, if we want that as a decimal, what we can do is just put the 4 down, and then on our calculator, treat the 1/3 like dividing. So take 1 and divide it by 3, and look at what comes after the decimal point. Okay. So 4 1/3 is going to be 4 point. If I do this dividing on my calculator, I get 3, 3, 3, and so on forever and ever and ever and ever. Okay. 3, 3, 3, 3, 3. So now I have 4.1 and 4.3, right? Well, which one's bigger? The 4.3 is bigger, right? So that tells me that 4 1/3 is bigger than the square root of 17. So notice that we have the small one first, and then our alligator is eating the bigger number, which is 4 1/3, okay? Because we just decided 4 1/3 is bigger than the square root of 17 because 4.3 is more than 4.1. 1 is more than 3. Okay, so we're going to write things as decimals if they are not already written as decimals, and then decide which one is bigger than the other. Okay, so now what I'd like you to try is got it number 4a here. What is an inequality, or just order these two numbers for me. Show me which one is smaller and which one is bigger between the square root of 129 and 11.52. Okay, this one's already written as a decimal for you. Don't have to do anything with that, but we do have to change this guy into a decimal. So that's step one. Write that as a decimal, and then write an inequality or show me which one of those is bigger. Okay, so pause the video, figure out which one of these two numbers here is bigger, and then come on back and I'll show you what we should get. Okay, square root of 129, when we type that in on our calculator, we get 11.357, and it keeps going, right? So we could round that up maybe to 3.4, because this is a 5, so we'd round that up to 11.4. So 11.4 is the square root of 129, and our other option was 11.52. So I believe 11.52 is the bigger one here, right? 11.52 is bigger than 11.35, right? So I'm going to write this inequality by saying square root of 129, and then 11.52, and I want my alligator to eat the bigger cookie, so I'm going to open it up this way to eat the 11.52 because that's the bigger one. Okay, so 11.52 is bigger than than square root of 129, which is 11.35. If you have any questions about ordering numbers or doing square roots on your calculator, please make a note to ask me in class tomorrow. Also, if you have questions about the vocabulary from the first slide, any of those types of numbers, please make a note to ask me in class tomorrow. Otherwise, that's all I have for you. Have a wonderful night.